So in today's video, we're going to go ahead and take a look at integrating piecewise functions. And so just as a little bit of a review of the properties of definite integrals actually, here if we're taking the definite integral from a to b of f of x dx, then we can kind of just separate this out into two different integrals. We can write this as the integral from a to c of f of x dx plus the integral from c to b of f of x dx, and here of course c has to be contained within the closed interval from a to b, right? And so you can go ahead and try to prove this property. It's actually very fun, and I actually do encourage you to do that. It's a very simple proof, but we're just going to go ahead and delve into a couple of examples of how we can actually apply this in order to take the definite integrals of piecewise functions. And so over here we're taking we have this function defined, this function f of x right over here is defined as secant squared of x whenever x is less than 0, and 3x squared plus 1 whenever x is greater than or equal to 0. And then we're asked to take the definite integral from negative pi to 2 of f of x dx. And so the first thing that we can do is we can kind of think, we have these bounds of integration over here, and x is defined in two different ways over this interval. From negative pi all the way to 2, we have two different definitions for x, right? Because x changes definitions when x is equal to 0, or f of x changes definitions when x is equal to 0. And so we can go ahead and separate this out at this little bound over here, at this bound, this piecewise function bound where f of x changes its kind of piecewise definition. And so let's go ahead and do that. We can write this as the integral from negative pi to 0 of f of x dx, right, plus the integral from 0 to 2 of f of x dx. And so this right over here, this just follows from this property that we discussed right over here, where we can kind of just pick some number, and 0 would be a very easy and optimal number over here because it's where the function changes its definition, and then we can kind of just separate out the integrals. And so let's go ahead and see this. So over here from negative pi to 0, f of x is defined, this is when x is less than 0, f of x is defined as secant squared of x. So we can go ahead and rewrite this as the integral from negative pi to 0 of secant squared of x dx plus, and then over here the integral from 0 to 2, that's when x is greater than or equal to 0, so f of x is defined as 3x squared plus 1. So 3x squared plus 1, and our bounds of integration are 0 to 2, the dx over there, and then we can just go ahead and integrate. So secant squared of x, we know that the integral of that is just tangent of x, and we're evaluating that from negative pi to 0 plus over here 3x squared plus 1, the integral is going to be, what is that, x cubed plus x. Of course, we don't need the plus c because it's a definite integral, evaluating that from 0 to 2. And then over here, tangent of x, we're kind of just evaluating tangent of 0 minus tangent of negative pi. Tangent of 0 is 0. Tangent of negative pi is just the same thing as negative tangent of pi. And we know that tangent of pi is just going to be equal to 0. And so this entire term over here will just become 0, which is a very nice simplification. Over here, x cubed plus x, evaluate that at 2, we get 2 cubed, which is 8 plus 2, and then we're subtracting it evaluated at 0, but when we evaluate this at 0, we just get 0. And then this ultimately will become 8 plus 2, which is 10, and that is our final answer right over there. So it's very simple. We just kind of have to look at the bounds of integration and look at how f of x is defined. And then over here we have another quick example. F of x is equal to e to the x when x is less than or equal to 0, and then sine of x when x is greater than 0. And then we're taking the integral from negative natural log of 2 to pi over 2 of f of x dx. And so let's go ahead and again just separate out this integral into two different bounds of integration. Again, we're going to want to pick 0 as our c value in this case because it's just where the function changes its definition. Alright, so this is going to be the integral from negative natural log of 2 to 0 of f of x dx plus the integral, oh, that's a very ugly integral sign, the integral from 0 to pi over 2 of f of x dx. And as a matter of fact, I'm actually going to let you to go ahead and continue this problem. Just do exactly as we did in the previous problem. Just take a look at what x is defined, or f of x is defined as over these two different intervals, and ultimately you should end up with this integral being equal to 3 over 2 if I am not mistaken. And so that's kind of just it for piecewise functions. The next video, we're going to actually look at absolute value functions and see how, these are very much correlated, because an absolute value function is just a piecewise function. And so definitely make sure you are comfortable with this notion so that we can actually delve into integrating piecewise functions, or sorry, integrating absolute value functions.